Hi guys, this is Vicky here again, and we are continuing with the 2015 AP Chem FRQ question number 5. So question number 5 says, they give you an equation and its X products are being produced and they are going from blue to colorless. So blue food coloring can be oxidized by household bleach, which contains OCl- to form colorless products as represented by the equation above. A student used a spectrophotometer set at wavelength of 635 nanometers to study the absorbance of the food coloring over time during the bleaching process. In the study, bleach is present in large excess so that the concentration of OCl- is essentially constant throughout the reaction. The student used data from the study to generate the graphs below. So we have the graph here and we are looking at it. And question number 1 says, based on the graph above, what is the order of the reaction with respect to the blue food coloring? So first thing first, if we're looking for orders, we are looking for a graph that is going to give us a straight linear line. The only one that has given us a straight linear line is this one. And if you look, the axes are ln over time, right? So based on that, we know that this is first order, okay? We know that it's first order, because if it were zero order, it's always going to be just absorbance versus time. Okay, first order, it's always going to be ln of absorbance, okay, over time. And then if it's second order, it's always going to be 1 over absorbance over time. Okay, so if you keep this in mind, it'll make your life so much easier. Okie dokies? Okie dokies. Alright, second. The reaction is known to be the first order with respect to bleach. In the second experiment, the student prepares solution of food coloring and bleach with concentrations that differ from those used in the first experiment. When the solution are combined, the student observes that the reaction mixture reaches an absorbance near zero too rapidly. In order to correct the problem, the student proposes the following 3 possible modifications to the experiment: increasing temperature, increasing concentration, and increasing concentration of the bleach. Circle the one proposed modification above that could correct the problem and explain how that modification increases the time for the reaction mixture to reach the absorbance near zero. So we basically want to kind of slow it down, because he's saying that it almost immediately went to zero, right? So if something goes almost immediately to zero, it went zero too rapidly, it means that the reaction took place a lot faster and we got rid of the food coloring. So the food coloring was blue and then we put in bleach, and for some reason we probably interacted this really rapidly, and the best way for this to interact really rapidly, some of the things that would increase the rate of reaction would be increasing temperature or increasing reactants, right? But which one would we increase to not allow for the color to change to clear rapidly? We would actually increase the food coloring, right? Because if we increase bleach, it's gonna go much more faster, right? And if we increase temperature, again, due to kinetic energy, the molecules are going to collide much faster at a much faster rate, and it will go colorless faster. Okay? Alright, so last question. It says, in another experiment, a student wishes to study the oxidation of red food coloring with bleach. How would the student need to modify the original experimental procedure to determine the order of the reaction with respect to the red food coloring? So, red versus blue, we understand that blue here, the wavelength is at 635 nanometers. So red is probably going to be in a different spectrum, right? So for that question, for C, we would actually set the spectrophotometer at a different wavelength, okay? At a different wavelength. That's what we would do. Okie dokies? Okie dokies. Cool, and I will see you in the next video.